homework tonight, too. Your homework tonight looks just like your quiz. All right, question 1. No, you cannot have a quiz for homework, but your homework looks just like the quiz. All right, let's look at Gibbs first. What you need, Zoe? What quiz? Collision theory, potential energy diagrams, phase stuff, the graph stuff we've learned how to do, like triple points on the phase diagrams. The Y graph. Remember the Y graph we drew? That. Yeah. Collision theory. Potential energy diagrams. We did Monday and Tuesday. Yeah, that stuff. Yeah, like that. All right. Number 1. All right. If you look at number 1, in what conditions would delta G always is always negative? When delta H is what and delta S is what? All right, so I'm asking you, in order for delta G to always give you, all right, in order for delta G to always be negative, what does these two numbers here have to be? That's right. You want this one to be negative and this to be a what? A positive. Because a negative times a positive will give you a what kind of number? Negative. A negative. And if this is negative, when you add these two things together, what are you going to get? A negative. So you need delta H to be negative and you need delta S to be what? A positive.
How do you find delta H?
Delta H is enthalpy, the heat. Remember, we're not going to actually calculate it. Okay?
Oh, you just like their signs and stuff. Like
their signs. The only way you'll know delta H is by the fact that it's either on this side or it's on this side. Huh? When we graph? Okay. So if you look at the graph, if you have a graph like this, is delta H positive or negative? Can anybody tell me? Is delta H positive or negative? How do you know it's positive? That's right. The products are higher. Because the products are higher, that's what tells you it's endo. So if it's endo, that tells you delta H is what? Positive, because you said it was endo. Okay? That's all you're going to have to know about delta H. We're not going to attach any numbers to it. XO is negative.
And then when it's asking for reverse, you switch the sign.
Yes.
And this on the quiz tomorrow.
Now, huh?
This on the quiz tomorrow.
This would be on today's quiz because that's a potential energy diagram. Okay, that's part of today.
We're gonna have a phase diagram.
A phase diagram would be,
or is that the?
Would be the Y graph. A phase diagram is like that. That would be fair game for today with the solid, liquid, and vapor.
On that one, what's the critical point?
The critical point is the end of the liquid vapor line here.
I thought it was no.
What's the one in the middle?
That's the triple point.
Quiz too. Today?
That was from Friday. That's fair game for today.
Okay.
So we doing the potential energy diagram, and then this one.
That's today.
Just those two.
Collision theory, like what are the two parts that you need to have a successful collision? That would be today. The 5 factors that affect rate would be today. Any of that would be fair game for today. All right, so if we finish the homework. So the next question said, what 2 factors would make delta G positive then? So what would you have to change delta H to be positive? A positive delta H, and what would you do to delta S? Make it negative. Now, the next question says, what would make it indeterminate? Okay, meaning it could sometimes be positive and sometimes be negative. Karen, get off the phone. Okay? A low temperature favors which of these values? All right, if this temperature is low, which one of these numbers is going to be a bigger factor? Well, if this is a small number, this is going to be a smaller quantity, so it's going to favor what? Delta H, so it's going to favor enthalpy. But if temperature is high, it's going to make this a bigger number, so it's going to favor entropy. Okay? That would be if we had actual numbers, yes. But we're not going to have actual numbers. All right, so 4, 5, and 6 are what we've been working with homework. Okay? So, number 4, if I write the equation on the board. All right, we have NaOH is a solid. And it becomes Na is an aqueous plus OH. Whoops. Is an aqueous, and they have the energy over here. All right, is it endo or exo? It's exo, so we know delta H is negative. And what can you tell me about delta S? Is it increasing or decreasing if you're a solid and you become aqueous? It's increasing, so it's positive. So if delta G is negative minus a positive, negative, subtract a positive, that becomes a negative. So we're adding a negative. What are we going to get? We're going to get a negative. So will it always be spontaneous? Never be spontaneous, or sometimes be spontaneous? Will always be spontaneous.
So positives are
Negatives. Positives are never spontaneous because they're not spontaneous. Okay, the next one, number 5, you have the energy over here. You have 2 hydrogens is a gas plus oxygen is a gas, and we become 2 waters as a liquid. All right, so what can you tell me about our delta H? Is it endo or exo? It's endo, right? So are we positive or negative?
positive.
We're positive because we're endo. What can you tell me about delta S? Are we increasing or are we decreasing in entropy or disorder? We're decreasing, so we're negative. So delta G is delta H minus T delta S. So delta H has what sign? Minus a negative. What happens when we multiply these negatives? So we have 2 positives that we add. So are we always spontaneous, never spontaneous, or sometimes spontaneous? We're never spontaneous because we're positive. And the last question, you have energy plus water as a solid. That's a really bad solid. And you become water as a liquid. All right, so what can you tell me about our delta H? It's endo, so we have what sign? And what can you tell me about delta S? It's positive or negative? Are we increasing or decreasing? So it's positive. All right, so here's a trick for you. Anytime they have the same signs, okay, both negative or both positives, they're sometimes spontaneous because you would need the numbers, okay? You won't be able to tell whether they're positive or negative unless you have the temperature because you won't be able to figure it out, okay? You would need the numbers to figure out the numbers because what you're going to wind up with is a positive, subtract a positive, and you're going to wind up with a positive added to a what? A negative. Can you figure out what the number is without the actual numbers if you have a positive and a negative? No, you need the numbers to know. Okay, so anytime they're both the same time, both the same sign. Both the same sign, you got to have the numbers to know whether it's always or never. Okay?
We have questions like that in our
No, not tomorrow's.
Our questions
Test, yes. Quiz, no. Say what? How will the quiz look? Which quiz? It's multiple choice.
I know. Like, what are you going to be asking?
Hard to say. Yeah.
I don't understand this. I'm just done, okay?
Okay.
Like, this one look weird.
It's a phase diagram.
I know, but I don't get where.
Did you watch any of the video from Friday?
No, I watched some of it, but I was kind of confused on the little graph thing.
Let me do that one.
Right. You need to refresh our memories.
I'm not going to spend all this time doing this. I'm going to show you one, and I'm going to answer a couple quick questions. But when y'all are out, it's your job to catch up. What's your question?
Where's the solid phase?
The solid is always here.
Solid, liquid, and vapor. Solid
is always in this section. Liquid is always in the center. The vapor is always below. It never changes. Yes, vapor is always gas. Vapor and gas are the same thing. Okay? It's always solid to the left of the Y. The liquid is always in the center of the Y, and vapor is always below the Y. The triple point is always at the intersection. That's always the triple point where they intersect. Okay? The critical point is always the end of the liquid vapor line. All right? The normal melting or normal boiling point, you have to find the standard pressure. So where's standard pressure on this graph? What? Okay, 1. So where they intersect at the liquid vapor line would be the boiling point, okay? Because that's just like the equilibrium vapor pressure graph we did. You remember we did the equilibrium vapor pressure graph on like Thursday of last week? Okay, so liquid vapor line right here would be your normal boiling point, okay? So when you say normal melting point, what line would you cross for melting? Yes. So right here where we cross the solid liquid line, that would be your normal melting point. And what's the opposite of the melting point? Freezing point. So that'll be your normal freezing point. They're the same point. Okay?
You said that's always 1 atmosphere.
That's all. It's always at standard pressure because this one's in atmospheres. It'll always be at 1 atmospheres. But if this graph was done in torr, you would look for what number? The 760 and do the same thing. Draw a line in.
Will there ever be a KPA or PA?
KPA is yes. The PA, no, they generally don't use PA because that's always got that times 10 to the 5th. So they're not going to use one that's that size. Okay? Anything else? Yes, no? Okay?
Increase the pressure causes substance to freeze.
It would freeze because what's happening to your solid section? Is your solid section growing or shrinking? Okay, it's growing. So since the solid's getting bigger, it's freezing. Anybody else?
Well, we need a calculator for this.
I will check, but I don't think so. But I will double check. All right, can we do the multiple choice homework I gave you?
And the temperature and pressure, which all three positions that to be the
That's the triple point. So read down and you'd get the temperature at 45. Pressure, you'd read over, whoops, and it'd be 0.5. Does that make sense? All right, so let's look at the multiple choice real quick.
How many questions are on this quiz?
11. It's an odd number. No, it's 11. All right, question 1. The answer is C. Question 2, B. Question 3, C. Question 4, D. Question 5, C. 6A. 7C. 8B. Sorry, that's D. I read my answer wrong. I'm looking at 9. 8 is D. 9 is B. 10 is D as in dog. On the back. 11 is C. 12 is C. 13 is A. Anything bothered you about the multiple choice? Crystalline can be defined in 2 ways. You can either talk about the particle arrangement, and if you do, the crystalline has a fixed geometric pattern, and amorphous is random. Or you can talk about the melting point. Crystalline melts at one fixed temperature. When you hit that temperature, it will automatically liquefy. But amorphous melts over a range. It usually gets soft and sticky. I hope none of y'all ever do this, but if you accidentally set a plastic bag or like styrofoam or rubber on something, it'll get soft and gooey first. And then if you pick it up, there's sort of stringy parts hanging from it when you pick it off the hot surface. Crystalline will melt at one temperature. It won't do that. The fixed geometric pattern. So crystalline is fixed and amorphous is random. Gotcha. Anybody else?
When I talk about like stress, what is stress?
Stress, we're going to talk about that tomorrow. The 3 stresses a system can have will be temperature, pressure, and concentration. So when we talked about like the vapor liquid system, when we talked about evaporation, when we talked about the boxes, when we changed the temperature and we made the particles evaporate faster, that was a stress. Okay, tomorrow we're going to do it with chemical equilibrium, and we're going to cause the equilibrium to shift by heating it, by changing its pressure, or adding more of one material by changing its concentration. Any other questions on the homework? No? She's just going to be deaf.
Bro, I saw her at the YMCA the other day, and I was like, I thought it was just like some teenager or whatnot. And all of a sudden, she's like, don't let her come in or something. I realized it was Miss Bowers. I was like,
anybody else?
saw that big old tattoo.
All right. In that case, you need a writing utensil. Let me see if you need a calculator. I do not know if you do or not. So let me look. So the only 2 additional lab reports I was getting today are Marissa's and then Tomas. Yours are graded there in Power School. I will probably hand those back tomorrow after I get a few more late ones today.
Can we redo a lab report?
As bad as they were, I don't think about it.
Yeah.
They were like super bad.
I told you I was crying. I was stressed. I couldn't figure it out.
Some of them were bad because they just weren't done. Some of them were bad because y'all left out whole sections. All right, Jake, hold up. Oh yeah, Fred. I don't think I have a calculation on here. I don't. You don't need a chart. You don't need a calculator. You're gonna need a what? No.
Is this an L?
Where? Yes, that's an L. Really, it's computer generated and you're still asking me what the letters are.
I mean, it looks like an E.
It's an L.
What's in there?
In number 1, where it says S beside water, and then she said it looked like an E, it's an L.
Why don't you do that as an actual?
It's computer generated. I have a test bank. It's not even my handwriting or my computer. John, let's move the camera behind you. And remember, those handy dandy lines are for you to write the answers on.
Okay.
Oh, and who am I missing today? I know Marissa and Tiffany are with Miss Rector. Am I missing anybody besides them? I don't see Justice. He's not singing. Just Justice. Just put your calculator up. You'll need it for today. I asked you that. Not the quiz. I asked you if we're gonna need it at all. He said no. Oh, no, I didn't understand. I thought you meant just the quiz. Yes, we'll need it today. We're getting ready to learn how to do some math problems after. I'm sorry, I'm right here. We normally do that. What we've been doing for 15 or so weeks.
He's been on this. He's been on, okay.
I know you were sick,
Um,
but you want to use all this?
so,
Points?
gotcha.
You got two, yeah, you get 5 for each one you have left.
Yeah.
And so far you haven't used any, so yeah. So you have 2 remaining. So take the vest on the back side of the door. Yeah,
I'll go ahead. Okay.
did you finish your quiz? And just hand it in. Since you're leaving, you bring me your quiz. Put your calculator in the tub. And throw your transfer line.
Yeah.
Tomas. Oh, I forgot what his name. I'm so sorry. Who's still working on the quiz? I got 1, 2 hands. No, Jade's just got a hand from here. So, Darlene.
We should watch a movie.
Nope,
Might as well.
never gonna happen.
You ever seen Finding Dory?
Yep.
Never
Good
seen
movie.
History of the World, I guess.
Overrated.
No.
Yeah.
But. Yeah, we might still be sick. Done, darling? All right, first first. Who's the front? Come on, collector. Are you missing one of the options, darling?
Yeah, I am.
Oh, yeah, yeah. No.
Come on. Come on. All right, find your notes. Let's talk about equilibrium today.
You got more?
No way.
That thing is wild.
All right, so we're going to talk about chemical equilibrium today. And we're going to learn to write a K equation, and we're going to learn to calculate K. Now, writing K and calculating K are the last two questions on your quiz tomorrow. All right, so 20 points of your 100 come from writing and calculating K. The other 80 come from what we did in the opening, figuring out if it's endothermic. Is it positive or negative? Is it increasing or decreasing in entropy? What's delta G? That's 80 points in the quiz tomorrow. The other 20 comes from doing this. Now, and these are typed because I did it for Chem 2 a long time ago, and I just trimmed it and shortened it for what we need.
Chemistry too?
This is chemistry, Ms. Wall.
What?
This is just chemistry.
I know, so I trimmed out all the crap I didn't need. All right, so we're going to talk about an equation of colorless N2O4, nitrogen 4 oxide, or you could say dinitrogen tetraoxide, right? Everybody remember how to write old system names?
Yes.
Sure. I like that answer. That means you don't know.
Yeah.
All right, so if we want to write an old system, the prefixes go on the front, right? So how many N's are there?
2.
So we write what prefix on N? Di, and what prefix on O?
Tetra.
So dinitrogen tetraoxide. All right, it's colorless and frozen. At room temperature, it's going to fall, right? Well, it's going to decompose into NO2. How do we write its name?
Nitrogen dioxide.
Nitrogen dioxide. Okay? Now, this is actually a reversible reaction. Now, remember, when we talked about chemical equilibrium, we said in order to have chemical equilibrium, reactions have to have how many processes? 2. You have to have 2 opposing processes, and they have to occur how? Equal rates. Okay? So, this is one process. And you'll notice that I drew one arrow. Now, part of our discussion today is going to revolve around how to draw the arrow. Huh? Much younger than I am. All right, everybody caught up? Did I give Sophie a chance to get caught up?
Yeah.
Okay. So, at some point, the color is going to stop changing. Okay? And we're going to have a mix of these two things. Now, when we have the mix of these two things, something else is going to happen. The NO2, on the next slide, is going to start to decompose back into the N2O4, which I have on the next slide. Okay? So, if the NO2 can start decomposing, or really reforming, the N2O4, we have the reverse process. Well, if we can get the reverse process going, we can have a chance at achieving equilibrium.
What is this?
Yes. All right, does everybody have it?
Wait. What do you mean color substitute?
So what?
What do you mean by color substitute?
What colors is it usually? What the color does it stop at?
I don't know. I don't remember.
So,
I'd have to look back.
hold on. In the blue section, it says it's colors, but then at the bottom, it says the color stops changing. That means it had a color at one point.
Yeah, I did in the notes. I probably trimmed all that out to shorten this for y'all. I'd have to go back to the original. Probably because somebody at one point told me it was too long, and so I trimmed it all out to make it short because somebody whined.
So there's something we're
So
missing.
It was frozen in white at one point, and I want to say it turns blue. If I'm not, but I could
You
be.
be drinking that
Colorless,
every day.
B6 blue.
Hold on, I can look real quick.
So it changes to blue,
No.
and then it stops.
It might not be blue. Let me look.
Exactly.
I
I
can
be
look.
drinking that every
Might be
day.
magenta.
It could be. I don't think it's magenta though.
The first time I used
I look. I don't remember. Been too long.
You can't finish it.
First time I did.
I'll tell you what the color is. It is clear. It turns sort of a yellowy color, and then it becomes rust, bright, sort of rusty red.
So like a mixture of red and
Mhm. Yep, rusty red.
Neat opposite.
Yep. That's the color change it becomes.
So,
Okay.
Okay? And when it becomes rusty red, it just stays rusty red. Does not go back to clear. All right, what? Now, I'm pretty sure I have that covered because we don't need it. Yeah, I better put it there. All right, now, we said there are two parts to equilibrium, right? Samaria already gave that to us and said that equilibrium is achieved when what two things happen? You have to have equal rates, and you got to have two opposing processes, right? So, notice that I have rates here, right? So, my opposing rates are this changes into this, and this changes into this. All right? So, they're opposites of each other. Now, what's in green, I'm not planning on writing. So those of you who write really fast and are faster than other people, you do not have to write the green because you already have it. Okay? Now, unless you just want to, but you already have it in your notes. I'm just going to highlight what's in the green. You were here. It wasn't an AP day. It would have been maybe Wednesday. The red, yes. Okay? Now, if you look at what's in the blue, okay, this that we just wrote, N2O4 changes into NO2, was what we refer to as the forward reaction, okay? N2O4 changes into NO2 is the forward reaction. And then, the part I left out with the colors, all right, NO2 changes back into this is the reverse reaction. And I'm going to go back to the previous slide and point that out. Now, if you listen to Samaria's definition and what's highlighted in green, you already have the green, but you can write it again if you want to. Equilibrium is a condition in which what two parts do we have to have? Two opposing processes. Now, several people on something we did last week struggled with this. It can be a physical process or it can be a chemical process. So last week when we talked about evaporation and condensation, we were talking about a physical process. Today, we're going to talk about a chemical process. Okay? Those rates have to be what? Equal. And you have to have two opposing rates. So our forward reaction is equal to our reverse reaction. So if I go back one slide for a second, when the reaction goes this direction, that is forward. Okay? When it goes this way, that is reverse. Does that make sense to everybody?
What do you mean when it goes this way? Like,
when it goes backwards. When the products reform the reactants. Okay, when these reactants or products on this side reform these reactants. Because remember, you can't have equilibrium if you don't have two processes. So these products on this side have to react to reform these reactants in order to ever get equilibrium. Some reactions won't do it. This happens to be one that will. Okay? Like when you dissolve sugar. Will sugar ever reform itself into solid sugar?
Yeah. No.
Not sitting in the bottom of a glass of water. So that's not ever going to achieve equilibrium. But some other reactions will. Yes, sir.
When those two things be the same?
What be the same thing?
Because like when
Yeah, but they're different compounds. That's why sometimes with some equations that are in old system, we write them differently because it looks like the same thing. All right. All right. So we got that. So we're here. Now, notice the arrows that I put on the board. We talked about this way back in, I don't remember, when we did the symbols of balanced equations. And I told you these were reversible, okay? These arrows mean reversible, okay? Reversible reaction. Now, the reason we haven't used them to this point is we haven't done anything that has a reversible reaction. So I tried very hard to make sure that I draw the reversible reactions and all the reactions when we're talking about equilibrium. I will admit I do slip up on occasion. So if I forget, are you okay over there?
No.
If I forget, just ask me and I will remind you to draw in the reversible reaction. But I try very hard to remember. But this is the only unit I have to draw the reversible reactions in. We do it for like 2 days out of 90. So if I forget, remind me and I'll draw it in. Okay? Now, equilibrium constants. This is the easiest topic we will do all semester. Oh, I got to go back? Sorry.
This is part of the same unit.
All the same unit. But writing K, the equilibrium constant, and calculating, the hardest part is using the calculator. Writing K and calculating K is one of the easiest topics we do all year. I'm ready for summer break.
It's only because
I'm not.
I'm so tired of people.
I got news for you. There are always going to be people, unless you're going to move to like an island.
The island and just live on.
Okay.
equally bored.
She's going to have Wi-Fi and text y'all the rest of your lives. Just to see what's going on.
She really don't bother me.
All right. So we're going to learn to calculate an equilibrium constant. All right. So now the nice thing about an equilibrium constant is it does not matter how much of any reactant or any product you start with. Okay? The amounts are irrelevant. Doesn't matter. Which is why this one's an easy one to calculate. We don't have to worry about how much we had, how much we start with, anything like that. Okay? It's irrelevant. Equilibrium can be achieved. We don't need that part. Okay? So, we just need to figure out how to write it, learn to calculate it, and figure out what it means. Okay? It's one of the easiest things we'll do all year because it's easy. We don't have to worry about how much we start with. We just need to know how much we have at that moment in time. Are you going to survive over there today? Okay. Darlene, did you die? Okay. Everybody got it?
No.
Really? It's 2 lines. It has 1 word on the 3rd line. All right. Now, for those of you who struggle with units, as sad as it is to say, some of you forgot your units on your lab report. K is unitless. Oh, it's one of the 2 unitless quantities in chemistry. K and pH are the 2 that don't have units. All right? K, capital K, is known as the equilibrium constant, not Kelvin. So if they say K equals something, they're talking about the equilibrium constant. They're not giving you a temperature. If they're giving you a temperature, where will K be?
On the number.
On the number, be at the end. Okay? So if they say K equals 212, they're telling you the equilibrium constant is 212, not the temperature. All right? K does not depend on the concentration of the reactants or products. K is only dependent on temperature. Do I need to give her the other mask?
Right.
Let's go see. All right. Now, fortunately for y'all, the state does not want y'all to memorize the rules for how K is dependent on temperature, so I'm not going to make y'all learn those. Okay? You just need to know that K changes with what? Temperature. Okay? You don't have to know if it's endo or exothermic or whether K changes based on that. You just have to know that K will change with temperature. So what will always be given in the question? Temperature. Will we do anything with the temperature? No, but it will always be given in the question because it's dependent on temperature. But we won't actually use it in the calculation. Okay? Are you with me on that? K is in the question or temperature is in the question because K depends on temperature, but we're not going to use the temperature. It's just always going to be given to us. It's a stopwatch. It's probably in my cabinet. Although it's in my cabinet, I don't know why it's beeping today because we haven't used it in months.
It's been big for the past 3 days.
I'll go to the next slide.
I don't know why.
I need to find some paper.
All right. So let's say we have this fake equation. Little a, big M, plus little b, big N, yields little c, big O, yields little d, big P. And they're all gases. Now, what do the little letters stand for? Not the ones in parentheses.
Oh.
The uncapitalized letters. What do they stand for? The what?
You're talking about the G,
No. The little, these.
the coefficient?
Yes, those are the coefficients. Okay? Like the balancing coefficients. What do the capital letters stand for? The elements are the compounds, and these are the what? Those are the states. Okay. Now, in writing a K equation, the states will be important, so they will always be given to you. Okay? States will always be given. All right, everybody got it?
No.
Yeah.
I can't fix it. You don't have paper. All right. So in writing K, rule number 1, you have to write the products over the reactants. Now, I will tell you, if you are asked to write or find one of these on the state test, one of the FOIL answers will do what to you? It will flip them. Okay? Guarantee it. If you have to write one of these on the exam or calculate one of these on the exam, one of the answer choices will be flipped. Okay? The products have to be on the top. The reactants have to be on the bottom. If you forget, you will get the wrong answer. The brackets stand for concentration. That'll be for the numbers. Okay? That's just shorthand for the concentration. So that's the way I'll write it. All right, number 2. Whoops. On the screen.
That's a point out.
Yeah. Number 2. All coefficients become what? All coefficients become exponents. If you don't have a coefficient, you don't have an exponent. But you have to balance, and if it has a coefficient, it becomes an exponent. Which is why I said, for a lot of you, the hardest part of this would be the calculator. Because you got to put in the coefficients to become exponents. And the last part, the only states that are included are which 2? Gas and aqueous. Okay? The only states that are included are gas and aqueous. So if you have a solid or a liquid, we're going to do what with it? We're going to cancel it out and take it out of the K expression. We're not going to use a gas, or sorry, a solid or a liquid at all. We're only going to keep the gas and the aqueous. Okay? The solids and the liquids are considered constant. They don't change significantly, so we consider them constant and we don't use them. Okay? So we have to do the products over the reactants.
What do you mean by constant?
It means they're not going to change.
I need to start packing up.
We are so close to the end of the year. Be patient.
When is our exam?
The 8th is makeup day. The 7th is Thursday, which is 4th period. The 6th is 3rd period. So the 5th will be y'all.
The 5th of June?
Yes.
Wait.
That's
What you say the testing days is like?
Huh?
What's the testing days like?
The test
Is it like 1 through 4? Or just first?
And we're 1st and 4th.
Oh,
Because they flip it when a lot of the seniors have 4th period exams, but because of the fact that all those exams that had constructed response are gone now, a lot of the AP classes now are all 3rd and 4th period. A lot of that's been eliminated, so they saw no reason to flip the schedule. So it's just 1st and 4th. So
What exam?
I got 2 exams.
that's not bad.
But we still gotta show up.
You have what? Oh,
That's our day.
well, that means you won't have one during exam
I
week.
ain't done.
You done? All right.
I wasn't, you know.
Oh, I thought you said you were done.
God, I thought you got.
That's what she said, or is that like during
That's if
our?
you don't even in your project.
Well, that's motivation to get it turned in then.
When is it due?
28, 29.
I was about to say 29th. When is that?
It's right after Memorial Day. Memorial Day is the 28th, so it'll be Tuesday.
My book, how long is your book? Mine's like 400.
That's what mine was, and I traded with mom.
But I'm on like 100 and something right now.
You got it, Xavier?
And I got like 200.
Okay. Xavier's finally caught up. All right, so now that Xavier's there. All right. I don't think I need what's up there. So if we look at what I have here at the top. Let's not do it that way. Let's go back here. All right, so if we look at writing the K expression for what's here at the top. All right, what are my products? All right, first of all, we always write K equals. You always write the K equals in a K expression. All right, what are my products?
CO and DP.
All right, first of all, the C and the D are the what? They're the coefficients. So what are the actual elements or compounds? O and P. So O in brackets and P in brackets. All right, the brackets stand for concentration. And they'll have the numbers in them. They're separate. Each compound gets their own brackets. Divided by, what are my reactants? M and N. All right, now, step number 2. Raise them to the exponents if they have coefficients. All of these have coefficients. So what coefficient is in front of O? What coefficient is in front of D? Sorry, P. The D. What's in front of the M? And what's in front of N? All right. So the last step would be to cancel out or get rid of anything that's not gas or aqueous. So when you look at your states, what did I use in all of mine? So is anything going to cancel out? No. Now, in my next 2 examples, I do have some stuff that will cancel out, though. I didn't give you stuff that's going to stay in both of these examples. So, You want me to give you a minute to write down number one?
Wait, what is that?
It's
That's 2O3 as a gas, and then 3O2 as a gas. Because ozone is becoming oxygen. That's what happens when lightning strikes the air.
The oxidation. Usually you have so little salt.
Oh,
So it looks weird.
What happens when lightning strikes?
ozone is changed into oxygen. All right, so if we look at number one, all right, what's the product in number one?
302.
Oh.
No, which one?
Oh.
Which O?
Three.
O3 or O2?
Said O2.
Okay, so K equals O2 is on top, right?
You knew what you was talking
Over, what's my reactant?
Oh,
O3. All right, do I have a coefficient on my O2?
yeah.
What? Okay, what coefficient do I have on O3?
Two.
Are either of them not a gas or an aqueous? So they both stay. All right.
Are the coefficients gonna matter?
Yes, because we're going to put numbers in these very shortly. As soon as we practice this one, we're going to put numbers in. All right? And I'll give you a minute to write down number two.
That's all right.
We have to balance this one.
All right. Do we need to balance that one, Sophie says?
Yes.
Coefficients over there.
For the bottom one?
No,
No, we
it's
don't
already
need balance.
balanced.
Yeah.
It's already balanced.
But are we ever going to have to?
Yes, possibly. Okay, if there's no coefficients, you should check because I may or may not have balanced. If there are coefficients in it, then I have balanced it for
You
you.
have a test on this?
Then you got 2 questions on it tomorrow.
Huh?
You got 2 questions on it tomorrow on the quiz.
I said test.
I'm still debating it in my head. After we do tomorrow's lesson, then I'm ready to test. I just haven't decided if we're going to. I got to sit down and see how many things I want to do before the exam and how many days I have.
No.
Still kicking around. All right, so what are my products?
CaCO3.
CaCO3. All right, what are my reactants?
CA and CO.
All right, so do I have any coefficients I need to put in?
No.
No, so we're on to step 3. Is there anybody who's not a gas or aqueous?
CaO.
CaO, so I need to do, take it out. Anybody else?
That's it.
It's just CaO?
Oh,
Yeah.
CaCO.
Yeah.
All right, so what am I going to do if my numerator canceled out?
Put a 1.
That's right. We're going to put a 1 if everything on top went away. So 1 over,
CO.
and who got to stay?
CO2.
CO2.
Cancel.
Okay? And that's all that's left in that K expression.
Okay, I have a question.
Okay?
So if all your denominators cancel out, you just write.
You just write whatever's on top. You wouldn't have to put a 1 in it if the denominator canceled out. Just if the numerator canceled out. Everybody hear Samaria's question? She said, what happened if all of the denominator went away? If all the denominator went away, would I need to put a 1 in the denominator?
No.
No, you only have to put a 1 if the numerator goes away. Okay? Can we put some numbers in it?
Sure.
Okay. All right. And this looks long only because all these numbers kept shifting my question. Okay? So write it down. We're going to calculate this. It's not any longer than any other problem we've ever written. The numbers just shifted everything.
Wow. You gotta write all these.
Oh.
Don't write it. I don't care.
I didn't say I wasn't gonna write it. I'm just complaining.
Which is the norm. Write half.
Right, whatever you feel is important.
Just write half the
I'm
question.
writing it all. You just gotta hear me complain.
Okay, yeah, that makes.
You need to ask the black how many more days we have.
So what?
If I don't have to listen to you complain.
I'm coming back next year.
Well, enough.
You gonna take physical science? No, Xavier said he was coming back and asked him, was he gonna say good? That's fine.
I thought Mr. Phillips teaches physicals.
Is this, oh, never mind. Oh, no.
Oh, is this?
Why would you that one?
Now, if anybody else has openings, by the way, I want to return those tomorrow. So if you plan to get full credit on those, I'm going to need openings. And I'm missing, looks like 1, 2, 3, 4, 5.
Did I turn mine in?
I don't have Justice, Marissa, Eduardo, Ashanti, and Baby.
Justin said he dropped out. Told me to tell you.
Oh, where is he?
He's taking a placement test for GCCC next year. Yes, and he wants to do a class there next year.
Focusing on them grades.
I'm decided to take my test to GCC.
Wow.
You got a volleyball team?
Yeah, they were good.
They were.
Yeah. They was garbage last year.
Did you play there?
No.
Did you play that?
Could I?
Yeah.
Yeah, because we had a few girls. They were some buns.
They're gonna have that on there.
I guess you were better than them.
Yes.
That's
1, 2, 3.
They used to be like really, really
5,
good.
6, 7,
Oh,
8, 8, 9.
I guess all of them left.
Oh, they left, cause I was like, what is this?
They got better.
Was
They
the
had
state
better
champions
choices.
good?
Huh?
Was the state champion good? Was that good?
Community college.
All right, you got it ready?
No.
No, but they would beat, like, they played like D2 teams and stuff like that, and they like beat them.
Ow. We really. Bye.
You know, like, you know how boys are. You know, some boys are dumb enough not to make the team.
Oh, it's a boys team?
No, I'm saying
Oh.
like,
I was going to say, I might do
that's how schools are. Like, especially that community colleges. Tomas, oh my God.
What the equation on too?
I'm terrified.
If there was a boys volleyball team, would y'all play?
Yeah.
It would be during
Yeah, I probably would.
this time.
Maybe so much.
Okay, you go ahead.
I probably would keep it.
All right.
It would be
So,
during this
what's the
time.
first thing we need to do? Or what is the first thing you should do tomorrow on the quiz?
Okay.
What's your name on
Right.
paper?
The name of the question, dingus.
Oh.
All right, so write the K expression like Sophie said.
Okay.
So, K equals what?
K equals,
H2O.
H2O,
Cl2.
bracket.
Cl2, over, what are my reactants?
HCl
HCl,
and then O2.
and then O2. Is everybody okay with Sophie saying write K and putting the reactants over the or products over the reactants? Everybody okay with that much?
Yeah.
Okay. So what's step 2?
The code?
Coefficient.
Coefficient. So I change my color up here. All right. What coefficient does water have?
Dose.
And chlorine has a,
Dose.
and HCl has a,
Four.
and oxygen has a what? So we're not going to do anything to it. All right. What are the states of all of them?
Yes.
So they all have to stay if they're all gases. Nobody gets eliminated. So now all we have left is to figure out what number each of them are and put them in the right place. Okay? That's it. So K equals what number is water? Look up here. Let me get rid of this.
5.8
Okay.
times 10 negative 2.
5.8 times 10 to the negative second. So 5.8 times 10 to the negative second. All right, what number is Cl2? 5.8 times 10 to the negative second. Over, what number is HCl?
1.2 times 10 to the
All right. What number is O2?
3.8 times 10 to the negative.
And then I just need to transfer all of my little exponents that we had. We had a squared here, we had a squared here, we had a 4 there, and we have a 1 there. All that is left is for me to do what? Now, typically, this is where I lose people. They have all of that, and then they're like, I didn't get that, Ms. Wall. How'd you get that number?
How did you get?
Punch it in and see if you can get it.
That's what I was asking.
Oh, what are you asking?
Where did you get the 2, and the 4 from?
Oh, those are the exponents. So you get to get, remember, coefficients become exponents. So these coefficients right here become their exponents. Right? Anybody get that?
No.
Hold on.
How are you entering it?
I think I need to go in mode.
I got this.
Like, are you doing
I
it
got
like
this, guy.
square?
Yes.
Like square them before you calculate it?
So I said 5.8, second EE negative 2, and then I hit squared. And then I said times 5.8, second EE negative 2, squared. And then I go ahead and hit equals. So I get a total for the top line.
Is it 1.1?
Times 10 to the negative 5. And then I say divide 1.2, second EE negative 3. And then I use my caret key for up to the 4th. And I go ahead and hit equals again and get an answer.
I got 1.4.
So I got some long number, 5,457,000.
I got 1.
Divide.
Wait for it.
All right, now I'm going to divide again because that's in the denominator. 3.8, second EE negative 4. Oops, I got 1.4 that time. I thought it was 1.4.
What'd you get?
1.43, which is what I thought the answer was. Times 10 to the 10th.
Hey, what?
That's what I got.
I thought it was 1.4 times 10 to the 10th.
That's why I got
See how you have that, it's times. You gotta hit divide there. It's got a little divide line right in there, because you're dividing by both numbers. See how you raise the 4th, and there's no divide line in there? You gotta have a divide line. You're dividing by both numbers of the denominator. You gotta have a divide line. Now, some of the things that like Xavier just had wrong, that some of the rest of you are probably gonna do also. If you're gonna do it like he did in a continuous line, divide. Both of these numbers are in the denominator. You got to divide by both. You cannot say divide that first number and then leave it as a multiply. The calculator is going to screw up the order of operation. You got to divide by both numbers down there.
Why can't I? Oh.
Okay.
You were fine. 5.8, second EE. Negative 2 squared times 5.8, second squared. It equals. Divide. 1.2, second EE, negative 3. I'll go back. 3. You need to put in your negative 3 exponents. Now raise that to the 4th. Okay, now divide by your next number, 3.8,
And
Second E, -4.
What's that?
Anybody else? Everybody, did you get it son?
Yep.
Yep, or you just tell me that's not going to leave you be.
So you leave me.
I'm never scared.
You got it. Get a calculator.
My bad.
Okay. Karen, did you get it?
come on, Seth.
What about you? Did you try it, or you just do the same thing Jay did?
What she said?
You really tried?
She's the first my kids gonna run on.
What you doing?
I would never said that.
That's messed up. That's messed up.
I really never. Sammy, get this stop lying. I really didn't.
These have changed you. Oh, yeah.
Plant change.
I'm dead. I better leave her alone.
Ever since
All right.
we came back,
Let's see.
like when Jane
All right. What if I use these two words? Would you know what I meant if I said homogeneous and heterogeneous equilibria?
Homo means same, hetero means not the same.
Okay. So what would be different if you don't need this bottom part here? Don't write this. We already talked about that piece. There. Now I know you won't write it because you're covering it up. All right. If I said homogeneous equilibria or heterogeneous equilibria, homogeneous equilibria just means they're all the same what? I said phases up there. But what's another word for phases?
States.
States. So in the equation we just wrote, all of them had the same what?
States.
They all have the same state, so they were all gases, right? So that would be a homogeneous equilibrium. But in one where you had to cancel out solids, for example, that would be a what kind of equilibrium?
Hetero.
Heterogeneous. So if I use those words, does that make sense now?
No. Don't you?
Yes, it will.
You just being obtuse over there today?
Oh, she called me big. So big. Boy, you really decided to get degrees. Everybody hurt my feelings today.
Especially Stephanie said that.
All right, that really hurt.
That's
Y'all just be picking up Stephanie. I'll tell you what, if Stephanie come and kill y'all.
What's wrong with you? She said she goes to the school.
That's what I need to do. I could give her the cat.
Oh, I wasn't done. Oh,
Karen, you wanna buy this from me for Vincent? No, but I want it for free. Yeah. Sorry.
What about this between boxes?
I want it for free, Karen.
Less.
How about you sell it to me for 10 cents and then I'll sell you both of these for $1.
Both of them.
How about I give you $25 and you do nothing back?
That's correct.
It's all good. It's all
Are we not on now? All right. So the last thing we're doing today, before we practice, is the magnitude of K. So we just calculated K. What does K mean? What does it tell us? What's the point of this and why I made you do it aside from you're in chemistry and I'm just being difficult? All right? K can be three things. K can be much greater than 1 or much less than 1. Now, notice that I drew 2 greater than signs up here. Okay? This means much greater than. Okay? That means much greater than. So, if you have a number that is much greater than 1, it tells you the forward reaction is favored. You have lots of products and very little reactants. It means the equilibrium lies to the right. And I'm going to explain that in a minute. Now, if you have a number that is much less than 1.
Does that mean negative or just really small?
Just really small. Won't be negative. It'll just be a really small number. Okay? That means the reverse reaction is favored. You get lots of products, lots of reactants, and there's very little products favored. Okay? The reaction lies to the left. Now, one that I didn't put up here, and I don't think I did on the next slide.
That's
So hold on.
considered much more. Than what you-
I'm going to talk, that's why I said I'd explain it. Okay? Now, if K is approximately equal to 1, okay? If it's approximately equal to 1, that means neither is favored. All right, and I'll let you catch up, and then I'll explain some examples and some numbers and talk about which one's which.
Why are you not singing today?
You like, oh.
Aren't you supposed to be singing?
Oh, our concert's soon. Holy crap.
What's the? Oh, I'm coming.
Y'all need the extra
What time it start?
practice.
7.
8.
I might come,
Is it free?
Yeah.
depending on how I feel.
Donations are at 7.
Y'all really take up donations?
And I barely eat chicken.
You barely. Oh, wait, can't make it. It's probably gonna be over at like 8.
Oh, no, it's gonna be long because they come out in middle school and the high school awards.
Oh, they didn't do it separate this year, like they did that one year?
No, yeah, they canceled yesterday's concert.
So it's probably gonna end at 9.
It's not that really late.
See, I'm still gonna be late.
It's gonna be so boring.
Is anybody doing any
So y'all have
solos
some
or
good stuff this
duets?
year?
I mean, the songs are good, it's just the awards are gonna be so boring.
Is the
What
dancing
the
good?
most improved, the best singer?
Generic
Most
awards.
outstanding does not mean best singer. Most outstanding person is best.
Who's gonna get it again?
Then she got me on the risers. Everybody is gonna see me. I don't know what I'm doing.
Oh,
Oh, yeah.
Just don't fall off.
oh,
Yeah.
Hold it.
I'll probably
It
go.
every
You
year.
know that boy Hope can sing?
Andy's
I
better.
gotta go home and prep.
Mason can sing.
The dancing or the singing part?
He be
I ain't never
overpowered,
seen
y'all.
part. Dancing part. I gotta practice.
I be hearing him over everybody. I'm like, dang.
Monster, remember Alex?
Hour two.
From my freshman year.
The white boy.
No.
No,
Oh,
the one that used to sing that
wow.
John Lennon song. Oh my God.
They rode his bike to Texas.
Yeah.
Oh my God, yes. He said, he
No,
told
no,
me
no,
that.
no,
Who told you what?
Are you caught up yet?
Oh, yeah, I've been there.
You still writing, dummy?
Still,
What are you writing then?
I ain't even done.
All right. So if you have a number, like, let me give you an equation.
And then you white your stuff out. That's why I say you so much.
Oh my God.
I need my whiteout back.
Where's your pencil?
I'm over here waiting on you to white out half your paper.
You need a pencil?
Right.
pencil.
What?
Why can't you just mark it out? Like, are you that type of person?
Nah. But since I got the white out,
Get my whiteout. I'll be here for days. You don't need any more whiteout. Remind me not to give him whiteout again.
come on.
No.
Don't do
All
that.
right. So if you have a K of 540, what would this tell us about this reaction if you have this K? Okay. Would we have a lot of N2 and H2? Would we have a lot of NH3? Or would we have a lot of all of it?
All of it.
All right. So if we cruise back over here, are we much greater than 1? Are we much less than 1? Or are we approximately equal to 1?
Much greater.
We are much greater than 1. Okay? So if we're much greater than 1, what's favored? The forward reaction, which means we have lots of what? Okay? So, because this tells us K is much greater than 1, we have lots of products. So, if we have lots of products, do we have lots of this stuff? No, because this is the what? What am I pointing at right here? I'm pointing at the reactants. So, what is this? These are the products, okay? So, we have lots of NH3. We have very little what? All right, so what are my reactants? We have very little N2 and H2. We made lots of ammonia. So if our goal was to make ammonia, we would have done that successfully. No pneumonia is if you get really sick and have a lot of chest congestion. Lungs are all messed up. All right. Now, let's say we have a K equal to 1 times 10 to the negative 8. Now, that's the same thing. Whoops. All right, if we have this, what can you tell me about that K? Okay, it's much less than 1. Okay? Shh. Savior. All right?
No, actually, I'll.
Jade. All right? K is much less than 1. All right? So if K is much less than 1, what does that tell us?
It has very lots of N2H2 and very little of NH2.
Okay, it has very little products, I heard. All right, and so Samaria was telling us what we had a lot of. We have a lot of what? Okay, so we have a lot of N2 and H2 and little NH3. Okay, but it's based on the size of the number. So you have to look at.
Figure out like the product. What'd you say about the product size?
It's based on the number. So since this number is so small,
No, I'm talking about like how we determine which one is the product.
whatever's on the right is the products. Okay? So when you look here, these are the products, these are the reactants. It doesn't matter that the arrow is reversible. It's the same rules we've always had. Whatever's on the left is the reactants, whatever's on the products are the right. Okay? That doesn't change. Okay? Everybody with me on that?
Yeah.
All right. Let's talk homework for a minute.
Homework.
We got 2 things.
We got nothing.
Well, you don't have to do it.
I don't know what I do.
All right.
I'll be here in
Is
the
it
morning for
A
help.
B day?
You don't have to do it. Then you
B
gotta
day?
face it, yeah.
Well, you know, it's always a possibility.
We got Jessup.
Hey, I'll be here in the morning for help.
All right. Give me Abel has handout papers about missing people. Here's your mom. I need responsible people who can hand out papers about missing.
Xavier.
All right, so be in your mom's house. Don't forget each other. And then I'll tell you which parts we got to do.
Why you say that?
It's you, buddy.
I was talking to work.
Yeah, you told her playing with the whiteout.
Yes.
Playing with.
Huh? Yeah, I'm working here.
Yeah, it's a whiteout, boy.
You missed the quiz. You missed most of today. You still got a lab to make up. Your missing work's ragging up. It's getting towards the end of the semester. You can get laid up and ASAP. Because once I set that last day for makeup work, I don't go back on it. So you had it made up quickly.
Thank God, baby.
You want another one?
Hey.
And this is sweet. Oh, yeah.
If you're gonna say something, don't say it in my face, okay? Say it behind my back so I can hear you.
Now that's mature. Alright,
Okay.
the paper that Tomas handed you. Alright, the one that has just the front side is a replica of your quiz tomorrow. Okay? Now,
An exact replica?
the questions are not identical.
Are
Okay?
they simple?
The format is identical. Okay? Format. 2 equilibrium questions, 2 thermodynamic questions on gives. Okay? The format is the same. Now, on this one, we've not done Chatellier. You're doing the calculations for calculating equilibrium constants. Okay?
Taking a
So these
tomorrow.
and these. I might check our work tomorrow. I haven't checked in a while. I might be feeling the tingle coming on. Okay, as Baby said, Just because I said you don't have to do it doesn't mean I won't
Get my
check.
grade up in here.
Okay?
Oh,
If you have lab reports
quit
and
playing.
you were here that day, you really ought to turn it in before you know you're at 20 points off tomorrow. Get them turned in. I will take it under advisement and tell you tomorrow. What are you doing over there bothering them, Xavier? Leave them be.
There's a scuffle in your class.
Jade, you and Xavier stop that